In the previous tutorial, I was talking about the operators, and the last topic was logical operators. So I hope all the points are clear now. And if you have any doubt, still if you have any doubt, then you can put your queries into the comment box. So we'll start from that portion, that is the logical operators. So we have already covered this. Next operator is called the bitwise operators. And the symbol by which we denote the bitwise operator is single and or XOR by caret symbol, and the not, that is tilde sign. This is the truth table for the bitwise operator. Since bitwise operators works on the bits, and the value of the bits could be 0 and 1. So just take two variable as A and B, and according to its value, that could be either 0 0 or 0 1, so it could be combination. So according to their combination, we'll find that what will be the output if we perform the AND operation, and what will be the output if we perform the OR operation. And similarly, we'll find that what will be the output of XOR operator if we perform the operation on bits. And then we'll see the NOT, that is tilde. This is a unary operator. So this will be operate on a single operand. We have already seen in the previous tutorial that there are two types of operators. One is called unary operator, and second one is called the binary operator. So this NOT symbol is the unary operator. So let's see. If first bit is 0, that is A, and second bit is 0, and if you perform the operation of AND, so it will be give you answer as 0. And if you perform OR operation, then you will get 0. If you perform exclusive OR, then you will get 0. And if you perform the NOT, then you will get 1. Since A is 0, so it will flip the answer. The idea behind this operation is, in one line, if I cover it, then I can say if both bits are 0, okay, or we can say if any bit is 0, and if you perform the AND operation, then you will get 0. Look at here. So here you can see both bits are 0, then answer is 0. 0 and 1, so any bit is 0, then answer is 0. So 0 1, so 0. 1 0, then 0. Here you can see that the both bits are 1 and 1, so we'll get the answer as 1 in AND operation. If you perform the OR operation, so the rule says if any bit is 1, then result will be 1. So here you can see 0 and 0, so both bits are 0, so we'll get answer 0, and the rest of operation will give you the answer as 1. 0 1 1, 1 0 1, and 1 1 is 1. If you perform the exclusive OR between the bits, so the rule says if both bits are same, then result will be 0. So look at here, 0 0, so both are same, then result is 0. 1 1, so both bits are same, then answer is 0. And if both bits are different, then answer will be 1 in case of exclusive OR. So 0 1 1, 1 0 1. If you perform the NOT operation, then it will flip the bits. If the bit is 0, then it will be 1. If that bit is 1, then it will be 0. So A is 0, so answer is 1. A is 0, answer is 1. If A is 1, then result will be 0, because it will flip this 1 to 0, and 1 1, then it is 0. So this is the truth table that will be used to operate the bitwise operation on the bits. Let's see with the example that how the bitwise operation will be performed. For example, if A is equal 6 and B is equal 3, and perform the operation A and B, okay, we can perform the operation A or B. We can perform the operation of A exclusive or B and not A. So first of all, we know that all the values will be stored in the bit pattern in the computer. So this will perform the AND operation of this bit pattern and this bit pattern. So look at here, the bit pattern of A will be, I'm taking the 8-bit pattern. So 0, 0, 0, 0, 0, 1, 1, 0. So this is the equivalent value to the 6. Okay, this is the binary representation. And if we convert the 3 in the binary, then we'll get 0, 0, 0, 0, 0, 0, 1, 1. So this is the bit pattern of 3. Now perform the operation of AND. So as we know that if both bits are 1, then result will be 1 in the case of AND. So look at here. Here both bits are different. So answer is 0. Both bits are 1. So answer is 1. Both bits are different. Means one is 0 and second one is 1. So answer is 0. And rest will be 0. So in this case, the value will be 0, 0, 0, 0, 0, 0, 1, 0. So this is equivalent to 2 in the decimal. So here you can see that the answer is 2. Similarly, if you perform OR operation between A and B, so here, this is the A's bit pattern and this is the B's bit pattern. And as we know that the OR operator will give you 0 in case of both bits are 0. So here 0, 1. So one is 0 and second one is 1. So answer is 1. 1, 1, that is 1. 1, 0, that is 1. 0, 0 will be 0. So in the case of OR operation between A and B, here you can see that the bit pattern after operation will be this one. Okay, and this bit pattern will be equivalent to 7. So answer is 7. Similarly, if you perform the exclusive OR operation, then here you can see that A's bit pattern and this is the B's bit pattern. And in exclusive OR, we know that if both bits are same, then answer will be 0. So look at here, 0, 1, 1, 1, 1, that is 1, 1, 0, sorry, 1, 1, that is 0, both bits are same, so answer is 0, 1, 0, both are different, then answer is 1. So this is equivalent to bit pattern. This bit pattern is equivalent to 5 decimal number, so answer is 5. Now look at the NOT operation that we are going to perform on A. So A value is 6, and when we perform the NOT A, then we get the answer as -7. So how this answer will be available? Just look at here. This is the A bit pattern, and after performing the operation of NOT, okay, so every bit will be changed, will be flipped. So 0 will become 1 and 1 will become 0. So this is the NOT A representation into the memory. Now just understand this. If NOT A, the first bit, the most significant most significant bit is 1. So that represents number is negative. So we know that the 0 will represent the positive number and 1 will represent the negative number. So it means this represents the negative number. So in case of negative number, so for negative number values, system evaluated 2's complement. So your computer will perform the 2's complement on the bit and print the magnitude with minus symbol. Okay, so look at here. So this is equivalent to the -6, that is 1, 1, 1, 1, 1, 0, 0, 1. So now, first of all, we will find out the 1's complement. So in 1's complement, every bit will again flip. So that is 1 will become 0 and 0 will become 1. Now find out the 2's complement. So in 1's complement, we add 1 to get the 2's complement. So here is the 2's complement of 6. Now this 2's complement of 6 is equivalent to 7 and will print the magnitude with minus symbol. So the answer is minus 7. Okay, so this is the bitwise operator functionality. Next one is shift operator. This is also bitwise operator. It also works on the bits. So this 2 times less than symbol represent the left shift, and 2 times greater than symbol represents the right shift. And the syntax for performing the operation of left shift and right shift is, we write first of all n, shift operator either left or right, and t. So n denotes the performing shift on the n bit, okay, the number on which you want to perform the shifting. And t means how many times you want to perform this operation. So look at here. For example, x is equal 6 left shift 2 times. Okay, so we'll get the answer as 24. So how? First of all, look at the 6 bits pattern. So 6 bits pattern is equivalent to, first of all, 4 times 0, then 0, 1, 1, 0. This is the 6 bits pattern. So we want to shift left side 2 times. So first time when you will shift, then this 0, that is the rightmost, will become at the second position, and this one will be shifted to here, and this one will be at this location. Okay, and this 0 will be outside of the memory. So now after performing the first shift, this bit pattern will be available. Since we want to perform 2 times of the left shift, so one more time it will perform the left shift. So again, now this 0 will be outside of this bit pattern, and every bit will be shift one more time to the left side. So now after performing the second shifting, this will be your bit pattern. So if you find out equivalent to the decimal value, then you will get the answer as 24. Similarly, if you perform the right shift, so you will get the answer as 1. So 6 right shift 2 times. So this is the bit pattern of 6. First of all, shift first time, then this 0, that is the rightmost 0, will be discard, and every bit will be shifted 1 bit at the right side. And since the operation says it should be 2 times, so after performing the operation on the second time, your bit pattern will become this one. Okay, this is the only one. This is by mistake, that is one type. Okay, so this is actually 0. So you will get the answer as 1. So this is the bit pattern operation by using the shift operation. Another operator that is available in Python is called the membership operator. So membership operator, there are two membership operators. One is called in, and second one is called not in. So in and not in are the membership operators in Python. They are used to test whether a value or variable is found in a sequence. Sequence means any object that contains group of elements. So a string can be your sequence because it is a group of characters. List can be your sequence because it can contain more than one value at a time, and value could be any type. Tuples, sets, and dictionaries. So if you perform the in operation, then it returns true if the value and the variable that you want to find out into the sequence is available. So then in that case, it will return true, otherwise it will return false. Not in returns true if the value and variable that you want to search is not found in the sequence. Okay. So for example, here is the variable that contains a value 10 and b is equal 20. And you want to search that this A, yani this A means this 10 is available in list or not. So you can write A in list. So look at here. So 10 is available into the list. So that's why it will return result as true. So we use this membership operators in searching operations. Okay, so this will become your task very easy. You don't need to write the looping constraint, and you don't need to compare every value every time if you have done in the previous languages like C, C++. So if you want to search any element into the sequence, you can use the in operator, that is membership operator. So it says that A is the member of the list. Yes, A is the member of the list. So it will return true. B is the member of the list. So yes, B is the member of the list. So it asks that B is not the member of the list. So it will return false. No, B is the list. B is the member of the list. So membership operator we will use further in many example. So understand this. Membership operator is used to check the members availability in a sequence. So for that, let me open ideally one more time. S is equal hello and world. Okay. Now I want to check that hello is available in the string or not. So I will write hello, uh, hello in S. So if hello is in S, then it will return true. Otherwise, it will return false. So yes, hello is available in the string, so it will return true. If you have any list, so don't worry. I'll cover what is the list in the coming tutorial series videos. So just understand that this is the collection of values 1, 2, 3, and you want to check this list could be your can have 1,000 of the elements. So if you want to check that if any element is available in that list or not, so you can perform the searching. So 1 in A, yes, 1 is the member of A. 10 in A, so no, 10 is not the part of this A. So this makes your code very easy. Another operator is called the identity operator. To understand this, just understand that what is the meaning of identity. Identity means the memory address. We have already seen the ID function to check what is the identity of an object. So identity operators are used to compare the objects, not if they are equal. Okay, but if they are actually the same object with the same memory location. So it could be possible that if you create more than one object, so in Python, those objects could be at the same location. So in that case, if you want to check that the objects are at the same location, then you can use the identity operator. So is and is not, these two operators are available to check the identity. So is and is not are the identity operators in Python. They are used to check two values or variables are located on the same memory or not. Okay, so if you want to check that the two values and the variables are at the same location, then you can use the identity operator. So is returns true if both variables are at the same location, and is not will return true if both variables are not the same object. So look at here, A is equal 10, one object is created, that is 10, and with the name of A, and B is equal 10. Let's see that A is B, so it returns true. It means A and B is pointing to the same object. To check that, we can use the ID function. So what is the identity of A? So this is the identity of A. This could be a random number. So in your system, it could be some other number. ID of B. So this is the ID of B. And you can find that the ID of A and ID of B, ID of A and ID of B is same. That is 1594 222 656. 1594 222 656. So it will check and tell you that if more than one variable is pointing to the same object, then it will return true, otherwise it will return false. So don't be confused, it will not check that the both variables having the same value. Okay, we are comparing the identity, not the value. Remember this one. If you want to compare the values, then you will use the relational operator, the comparison operator that we have seen, that is A double equal B. So this will compare the values. This will compare the address. A is B and is not B. Similarly, A is not B. That is false. Okay. So this is the identity operators in Python. So A and B that you can see here, A is 10, B is 10, A is B, it is true. So that's all for the operators. Still, if you have any doubt, then you can put your queries. Thank you for watching this video. Please subscribe this channel, and to get the notification of the latest videos, please press the bell icon also. If you like this video, comment, share, and like. Thank you. Bye-bye.